New chapter, loops. Imagine that you had to print numbers from 1 to 100. Imagine if you had to write print 1, print 2, print 3, print 4 until you write 100. It would be really horrible. This is why we need loops to repeat an action. Before diving into it, let's analyze this sentence. I eat again while I'm still hungry. What does it mean? It means that I will repeat the action of eating until I'm not hungry anymore. We can divide this sentence in two parts, the left part which is the action, and the right part which is the condition. The condition can be either true or false. So while our condition is true, which is being hungry, we repeat the action, which is eating. In other words, we repeat the action of eating over and over until our condition isn't true anymore. So before eating again, we check if the condition is still true, and if the condition became false, we just stop eating. Our last example represents the definition of a loop in programming. A loop is just the repetition of some instructions while the loop condition is true. And in the C language, we have three types of loops: the while loop, the do-while loop, and the for loop, that we will see in the next videos. You have to know that the difference between if statement and a loop is that the if statement will be executed 0 or 1 time depending on the condition, but the loop can be executed any number of times. See you in the next video to talk about the while loop. Welcome to this video where we will talk about the while loop. The while loop is one of the three types of loops in the C language. It has two components, the condition and the instructions. Before diving into the syntax, let's see how the while loop works. We represent it using this schema. First, we evaluate the condition. It's a Boolean expression, so we have two possible cases, true or false. When the condition is true, we move to the body of the loop and we execute the instructions. Then we go back to the condition and we evaluate it again. If the condition is true again, we do the same thing. We execute the instructions and we evaluate again. If it's true again, same thing. And we can keep going as long as the condition is true. And if the condition is false, we just move to the code that comes after it. That's it. So let's see an example. For example, we want to multiply a number by 2 while it's smaller than 10. For that, we use an integer variable named num, and we initialize it to 1. So now we can start executing the loop. What is the condition here? We said we repeat the multiplication while num is smaller than 10. So the condition is num is smaller than 10. And what is the instruction? The instruction is to multiply num by 2. Let's start the execution. We evaluate the condition. We have num is actually 1. Is it smaller than 10? Yes. So we execute the instruction. We multiply num by 2 and it becomes 2. Now we evaluate the condition again. Is 2 smaller than 10? Yes. We multiply. Num becomes 4. Is 4 smaller than 10? Yes. We multiply. Num becomes 8. Is 8 smaller than 10? Yes. We multiply. Num becomes 16. Is 16 smaller than 10? No, it's not. The condition is false. So we ended the loop and we just moved to the code that comes after the loop. Now let's move to the IDE to implement the while loop and see its syntax. The syntax of while loop is very simple. First we have the keyword while, then in parentheses we have the condition, same as for if statement, and then we have the body of the loop between curly brackets, where we put the instructions that will be repeated. But same as for if statement, if the body has only one instruction, we can avoid using curly brackets. Let's now take our example and implement it in code. First we have the variable num initialized to 1, and the condition was num is smaller than 10. Here is it. And inside the body we put the instruction num multiplied by 2. Now let's print the final result. Here we compiled and we got 16. Let's just print the value of num in each execution of the loop. Here we got 1, 2, 4, 8, 16, because the loop got executed 4 times before the condition went false. Second example, we want to print the expression loop executed 5 times. For that, we will use a variable named counter to count the number of times we executed the loop, and the loop will stop when the counter reaches 5. Take some seconds to guess what is the condition and what are the instructions of the body. As we said, the condition to continue looping is that the counter didn't reach 5 yet, so counter smaller than 5, and the instructions are printing loop executed and obviously incrementing the counter. If we don't increment the counter, the loop will be executed infinitely, and this is what we call an infinite loop. We will talk more about it later. We can also print that the loop is ended after it. And now let's execute to see the result. As you can see, we looped 5 times, and if we decide to see the value of the counter after the loop, it will be 5. Before moving to the next type of loop, you have to know that it's possible to have a case where we don't even enter in the body of the loop. It's when the condition is false at the beginning. For example, if we have this loop, we have n is equal to 10, and we have while n is smaller than 5, we print loop got executed. If we compile, we get nothing, because we didn't even enter to the loop because the condition n is smaller than 5 is already false at the beginning. See you in the next video to talk about the do-while loop. Welcome to this video. Now let's talk about the do-while loop, another type of loops in C language. First, you have to know that the while loop and the do-while loop are very similar but not totally. The main difference between them is that the while loop evaluates the condition before the first iteration and the do-while loop evaluates the condition after the first iteration. It means that even if the condition is false at the beginning, the first iteration of do-while loop will be always executed, as we can see in this schema. So we execute directly the instructions, then we evaluate the condition, and if it's true, we go to instructions again, and if it's false, it's the end of the loop and we move to the code that comes after. Now the syntax. A very basic syntax. We have the keyword do, then followed by curly braces where we will find the instructions inside. It's the body of the loop, and after closing the body we have the keyword while, followed by the condition between parentheses, and then we have the semicolon at the end. Don't forget it, otherwise you will get an error. And as you can see, the condition comes after the instructions. Now let's take an example to show the difference between while and do-while loop. Let's take this example wrote in both loops. First, with do-while. Do printf, we enter the loop while 5 is smaller than 2, and obviously 5 is smaller than 2 is false. But when we execute, we can see that we get that we enter the loop, because do-while executed the instructions before knowing that the condition is false. But if we do the same program but with while loop, we get nothing in output because the loop verified the condition before and found it false, so it didn't execute the instruction of printing. I'll put a link below to an Instagram post about this. And now we can move to the next type of loop, which is the for loop. Welcome to this video where we will talk about the third and last type of loops in C language, named the for loop. Before talking about it, let's just analyze a while loop that prints loop executed 10 times. First, we need a variable considered as an iterator and initialized to 0. Then we need the loop. The condition is that I is smaller than 10. And inside the loop we print loop executed, and then we increment I, otherwise we would get an infinite loop. So the elements we use are the initialization, the condition, the instructions, and the variable update. What if I tell you that there is a loop that makes it possible to write the initialization, the condition, and the update in one single line? It's called the for loop. Let's see its syntax. First we have the keyword for, then we open parentheses. Now we have 3 elements. We have the initialization, then we have semicolon, then we have the condition, then another semicolon, then we have the update, then we close the parentheses, and then we have the body of the loop. We can represent it with this schema. Initialization, then condition. If it's false, it directly stops. If it's true, we do the instructions, then we do the update, and we go back to the condition to see if there is another iteration to do. We don't initialize each time. The initialization is done only at the beginning. Let's use it for our last example. Print 10 times loop executed. The initialization is the variable I initialized to 0. You can declare it outside the loop, it's as you want. Then in the condition we have I is smaller than 10. And in the update we increment I, so I++. And in the body we print loop execution. And the update will happen at the end of each iteration, when the program arrives here. And when we execute, we get the same output as for the while loop. In the next video we will learn how to choose the required type of loop in different situations. But before, there is some points I want to clarify. First, same as the while loop, the for loop verifies the condition at the beginning, so if the condition is false, it doesn't even enter, and it just moves to what comes next. Second thing, we're not obliged to increment in the update. We can, for example, add 2 or 3 or as you want. You can also decrement, you can multiply, divide, it's as you want. So you're not obliged to go from 0 to n. You can start wherever you want. You can also start from the end. For example, you can print numbers from 0 to 10 but in descending order. So you start at 10 and you decrement I each time until you arrive to 0. Third thing, the syntax of for loop can be confusing at the beginning, but you will get used to it by the time. As I told you in the beginning of the course, don't hesitate to try things you thought about in programming. For example, if you want to know what happens in a certain situation, just code it and execute and see what happens. And if you don't understand why, just search on the internet. Take the habit to search on internet for programming. Now let's move to the next video. Welcome to this video. Now that we've seen the 3 types of loops in C language, we have to know which loop to choose depending on the situation. But first, you have to know that it's not a problem if you don't do the right choice, because the 3 types do the same thing, looping. So you can do the task you want with any loop. Choosing the right one is just a question of convenience. Now let's start. We start with a for loop. In general, we use the for loop when we know the number of iterations we will do. For example, if you want to execute something 10 times or 20 or 50 or any other finite number of repetitions, you choose the for loop. And if you don't know the number of repetitions and you want to verify the condition at the beginning, just choose the while loop. For example, you want to divide an integer by 2 until it reaches 0. You just use while loop because you don't know how many times you will divide and you want to verify if it's not already 0. Third loop, the do while loop. We generally choose it if we want to make the first iteration and then we verify the condition, because that iteration will affect on if we continue looping or not. For example, you want to get a number from the user that is between 0 and 10. You must do the first iteration to see if you continue or not. You can't verify the condition at the beginning because he didn't give you any number yet. So you wait to get the first number, then you see if it's a valid number or not. We finished our 3 loops, and by getting experience and understanding them, you will easily know which one to choose in the right situation and won't be confused about it. See you in the next video to talk about infinite loops. Welcome to this video about infinite loops. Before moving to the definition, let me ask you a question. In all precedent examples we've seen, the condition we put became false sooner or later, and the loop stopped. But what if the condition we put never becomes false? In other words, the loop never stops. This is what we call an infinite loop. An infinite loop is just a block of instructions that loops endlessly, because the condition of the loop never becomes false, so it never stops. And we have intentional infinite loops and unintentional ones, because sometimes we want to have an infinite loop intentionally. For example, in an endless video game where we want to have a new game just after the precedent one ends. So let's see how to build an endless loop. Before this, you have to know that in a for loop, we are not obliged to fill all the 3 elements. We can let them blank. For example, if our variable is already initialized and we don't want to initialize it again, we just let the initialization part blank. But we respect the syntax, we don't forget the semicolon. Or if we don't want to update the variable after an iteration, we let that part blank like this. So if we want to make an endless for loop, we can just write this. We let the 3 elements blank, and this will run forever. Or if we want to use a while loop, we can write while 1, because 1 is evaluated to true, and in fact true will always be true. Or you can put a condition that will always be true, for example while 5 is bigger than 3, or while 10 is equal to 10, it's as you want. And we can also have an infinite loop unintentionally. This is the one that we want to avoid, and it occurs when we don't make sure that the loop will end. We have common mistakes. For example, we reinitialize the variable inside like we did in this loop. In each iteration, I goes back to 0, so we will never reach the limit. Or for example, in this loop, we have I initialized on 0 and decrementing, and the condition says that I must be smaller than 10. This one will always be true. Or the most common mistake, it usually happens in while or do while loop, it's when we forget to increment the counter. Remember the example we did in while loop video. the one to print 5 times the loop executed. At the end of the body of the loop, we incremented the counter. But imagine if we didn't. The counter would be always 0 and would never reach 5 to stop. I hope you understood infinite loops. What if I tell you that there is a statement that directly stops a loop even if the condition is still true? We will see that in the next video. Welcome to this video where we will talk about the loop control statements, break and continue. What if I tell you that you can immediately stop a loop even if the condition is still true? Yes, it's possible. It's by using the statement break. The syntax is just the keyword break followed by a semicolon, that's it. It's generally used with a condition. It means you can put an if statement in the loop that will break the loop if it's true, and move to code that comes after. Let's see some examples. For example, we decide to get 5 numbers from the user, but we also decide to stop if he gives a negative number, even if we didn't reach 5 numbers yet. So the code would be like this. We have a finite number of repetitions, which is 5, so we choose a for loop, and inside the loop, after each given number, we verify if it's negative. If yes, we break the loop, and we print that we broke the loop. Now let's make some tries for it. We compile and we give numbers to the program. If we give 5 positive numbers, that loop will run normally. But if we decide to give a negative number, here is it. We got that we broke the loop and it stops even if we gave less than 5 numbers. We can also use break in infinite loops. Remember that I told you that it's possible to stop an infinite loop. It's by using break like this. Now let's move to the second loop control statement, the continue statement. The continue statement just skips the current iteration. It's generally used with a condition. Let's say, for example, you want to print numbers from 0 to 10, but you don't want to print the number 4. You just put the condition if I is equal to 4, continue, and you put it before all the instructions obviously. Or if you want to skip the numbers that are a multiple of 3, you can write if I mod 3 is equal to 0, continue. Here you won't get multiple of 3 as you can see. You may think, why don't we just use conditions? Yes, we can avoid using continue, but what if you had a lot of instructions? Putting in continue statement is more intuitive and shorter because it's a one-line statement. Now that we've seen break and continue statement, I want you to take the quiz that comes after this video to fully understand break and continue statements. And see you in the next video to talk about nested loops. Welcome to this video where we will talk about nested loops. What if I told you that you can put a loop inside a loop like we did with conditions? It's possible. It's called nested loops. And we will have the outer loop and inside we will have an inner loop. And it's not a problem if they aren't of the same type. We can, for example, have a for loop inside the while loop. So what will really happen? In each iteration of the outer loop, the inner loop will be re-executed from the beginning. An example is better to understand. For example, we will repeat the outer loop 5 times and the inner loop 3 times, and inside we print the values of I and G, the iterators of outer and inner loop respectively, to see how is the program working. We can see that in the first iteration we got 0, 0, 0, 1, 0, 2, then G arrived to 3 so the inner loop ended. So we move to the next iteration of outer loop, 1, 0, 1, 1, 1, 2, inner loop ended again. Next iteration of outer loop, 2, 0, 2, 1, 2, 2, and so on until the outer loop ends. And this is what happened. We can clearly see that the inner loop got executed 15 times, 5 times 3, which is 15. A good exercise to practice on nested loops is the star patterns. For example, if we want to print a rectangle with stars, we use nested loops. First we get width and length from the user, then we use nested loops. Let's try this program. We have 2 variables width and length that we will get from the user by using do-while loops to verify that the input is positive. And now the outer loop represents the lines, so we put the width, and the inner loop represents the columns, so we put the length. And inside we print the star, and after each line we put a line break to start a new line. And now we compile. If we choose width 3 and length 6, we get this rectangle. Try to do the quiz that comes after this video to practice on it. You have to know that nested loops aren't limited to only 2 loops. You can basically use any number of loops you want. And here we've ended the chapter about loops. See you in the next one.